Hey physics students, once again it's rapid review for honors physics. Today we're finishing up Newton's laws. We've already talked about the first and second law. Today we're going to talk about the third law. And if I rapidly switch through the slides we saw last time, I'm going to come up with the third law information. Here it is. I'm going to jump right into it. It's what you see on your screen. For every force, there's an equal and opposite reaction force. Let's parse that. What's a force? You already know that. It's a push or a pull. What's a reaction force? Oh, it's something pushing back or pulling back, opposite to the force that was applied. So equal means it's the same vector magnitude, but opposite means the opposite vector direction. That's why we say equal and opposite, and it's why we need both words in there, because we're talking about vectors. And so equal talks about the vector magnitude, opposite the vector direction. Okay? You may have seen demonstrations in the class. If I push on, I don't know, if I push on my hand here, my hand is pushing back on my fingertip, right? If I don't know, I'll come up with some demonstrations later. Any force that's applied to anything has a reaction force pushing back the other way. So I'll save the demonstrations for another time. But I could say it in a different word. I just tried different wording here too. For every force pushing or pulling on an object, the object pushes or pulls back with a force of equal magnitude and equal direction. Opposite direction. I just chose different words to say the same thing. But there's two caveats here. One is you have to keep in mind what is the object and what is external to the object, because it's the external thing that provides the reaction force. So when an external force pushes on the object, I'm going to emphasize that word, on the object, the reaction force is pushing back on whatever that thing that's external to itself. It's really important with the third law, and the reason I even made this a separate video is that third law pertains to two objects. In order to discuss the third law, you have to have two objects. There's object A and object B, and it talks about how they interact with each other. So keep that in mind when you're looking at third law problems. I also provide this handy test-taking tip. All you have to do is reverse the sentence, no matter how nonsensical it might sound. But if somebody says, the book is pushing down on the table, what's the reaction force? Your answer will be, table pushes up on book. And I claim it always works. Sometimes the answer doesn't seem to make sense, like elephant's foot pushes down on mouse, right? You feel like the mouse is getting squashed and it's just not fair. But it's true that with whatever force the elephant's foot is pushing down on the mouse, that same force is pushing up on the elephant's foot coming from the mouse. The forces are equal, even though it may seem to make no sense. You'll get more and more comfortable with this idea as you solve problems with forces. But the reaction force is always the same in magnitude, even if the example might sound a little strange to you at first. Okay, so that's the third law, and that lets us summarize. We have three laws now. Newton's first and second law are what we studied last time. The object at rest stays at rest, and the object in motion stays in motion, unless there's an external force. And what if there is? That's the second law. And as we just learned today, for every force, there's an equal and opposite reaction force coming from the object that was initially pushing on the object you were studying. Two objects are required. Two objects are required. Okay, so that's all I have for Newton's laws. We'll be moving on to new topics with our next edition of Rapid Review for Honors Physics.